Okay, number 28. And once again, we've got the algebra functions. Yeah, you could put this into your calculator, but I mean, you're just combining like terms, so my suggestion is you just do a pencil and paper. All right, there's f of x, there's g of x, and he's asking me to find f times g. F times g, actually, of x. So what ends up happening here, you're multiplying, it's going back to intro algebra where you're foiling. 9x times 2x, 18x, outside terms 54x, inside terms 16x, and last term 6 times 8, 48, so this is a squared, by the way, 18x squared. 18x squared plus 70x plus 48. Just a straight out FOIL problem. F times g, taking the two functions and you're multiplying them times themselves. And we've got letter A, 29, f of x, 2x plus 3, g of x, 5x minus 2. And he's asking me to find f divided by g. Pretty straightforward. The f function is 2x plus 3, and the g function is 5x minus 2. If you look at letters A and letter C has the exact same thing, but they differ as far as what's not allowed. What you're concerned about is the denominator being 0. You care less about the numerator being 0. You can divide it to 0 all day long. It's going to be 0. It's this denominator that can't be 0. So when does the denominator equal 0? It equals 0 when x is equal to 2/5. So that means that you can't use 2/5, because if you use 2/5, the denominator becomes 0 and the problem is undefined. So it's letter A rather than letter C. Letter C is looking at the numerator can't be 0. You could care less about the numerator. It's the denominator that is the issue. Number 30. We've got the difference quotient. And there it is. And the function he's looking at is f of x equal to x squared plus 3x minus 1. So first thing I need to do is find f of x plus h. So wherever I see x, I'm going to substitute in x plus h. So x plus h quantity squared plus 3 times x plus h minus 1 minus f of x. Well, minus is going to change all the signs in this. If I put it in parentheses, I'm going to subtract this whole thing. So my signs are all going to change. So that becomes a minus x squared minus 3x plus 1. And of course, this is all divided by h. Foiling this out, you get x squared plus 2xh plus h squared plus 3x plus 3h minus 1 minus x squared minus 3x plus 1. All right, this is all going to be over h. I'm not going to write that, but what happens now is all kind of good things happen. The 3x's cancel out, the x squares cancel out, the minus and the positive 1 cancel out, leaving me 2xh plus h squared plus 3h, those three terms. And I said there's one term there, and one term there, and one term there, and everything else is canceled out. This is all divided by h. Now, what invariably happens, all these problems, there's always going to be h factor in the numerator. So if I factor out an h, if I factor out an h and divide it by h, these two guys cancel out, and there we go. It's a lot of work, but no big deal. 2x plus h plus 3. And that looks like it is answer B. Number 31. x equal to 3 minus x. Find the domain. Well, you start out with the domain being all real numbers. The only situation that causes you problems is when you're presented with a fraction or a radical. When you have a fraction, the denominator can't be 0 like it was in the previous problem. All right, 5x minus 2 could not be 0. That means that x can't be 5/2. When you're presented with a radical, you can't take the square root of something that's negative. So this radicand always has to be greater than, worst case scenario, it could be equal to 0. Square root of 0 is 0, so that's good. So we have minus x greater than or equal to a negative 3, which implies that x is less than or equal to a positive 3. As long as your x values are less than or equal to 3, this radicand won't be negative and won't be 0. So your domain consists of these values here, x values that are less than or equal to 3. All right, this denominator had to be a positive value. All right, r is equal to 0, couldn't be negative. All right, 32. Composite function, all right, which translates to f of g of x, which translates to f of, now the g of x function is 3x minus 1. So what I'm doing is, into the f function, I'm inputting in the g function, which is 3x minus 1. So now I've got f of 3x minus 1. Wherever I see x in the f function, what's the f function? It's 6 times x. All right, 6 times x, but x now is 3x minus 1. And the f function says after I do that, I'm to add 13. So distributing here, I've got 18x minus 6 plus 13, which translates or simplifies to 18x plus 7, which ends up being letter A. Let's see if I can continue on here. 33. I'm not going to draw this one, but if you look at the top function, minus x plus 2, you know that's a line. It's a line that has a negative 1 for a slope. It's got a y-intercept of 2. Now this is defined for x values that are strictly less than 1. So here's my positive 2. This line slants downhill. All right. Now this is defined for values that are less than. All right, so you're going to have an open circle over here at positive 1. Now if I look at the graphs here, the only ones that have an open circle are letters B and letter C. It can't be A because A has a closed dot at 1, 1. And then the letter D, the line is not going downhill like it's supposed to because of the negative slope, it's going uphill. So I know my answer is either letter C or it's letter B. But the second function, square root of x plus 3, well, that takes the basic square root function and it just moves it up 3. It moves it up 3 units. All right. So if I look at this, my two choices were letter C or letter B. Well, the bottom part of B is not moved up, it's moved down 3, actually 2 units. All right, so my only other choice is, I knew it was either B or C. B's out of the mix, A's been out of the mix, D's been out of the mix. And the only way it makes sense is letter C. Yeah, you could graph this, but using some kind of common sense makes that problem really pretty straightforward. 34, no big deal. I mean, using transformation, here's what I'm saying. You could graph this in your graphing calculator. That's just, it's done. You put this into your calculator, you go, all right, what picture is it, A, B, C, or D? But if I looked at transformation, I know what the square root function looks like. It's this V-shaped function. This tells me to move it 3 units to the left, and then this tells me to move it 4 units up. So if I moved it 3 to the left and moved it 4 units up, I get something looking like that. which is obviously letter A. But once again, you could actually do this in your calculator in your own business. 35, same thing. Just graph that. You look at it and it'll be symmetric to the y-axis. All right, no big deal. Just put that into your calculator. And number 36, here again, you should recognize that as being the square root function. All right, and it's been moved 1 unit to the left. Now you would think that's a positive one, but in actuality, it's a negative one. So this is the f of x, or the function, whatever you want to call it, is x minus 1. Moving it 1 unit to the right actually translates to a minus. But once again, letter A you knew was a line. Letter B, if you graphed it, it wouldn't be what's pictured in 36. C is just a basic square root function, which starts at the origin. So you would have stumbled on it that it'd be letter D. But once again, if you're up to speed on transformations, you say to yourself, hey, that's a basic square root function. It's mean move 1 to the right. 1 to the right does not mean x plus 1. It means x minus 1. It moves it in just the opposite direction. That's the horizontal shift. When you have something outside of the radical, a plus or a minus, it's just what it is. Plus means move the graph up. Minus means move it down. Once again, you could have graphed all 4, but you knew A wasn't the answer. So the process of elimination.